In this video, we are going to learn about the standard position of an angle as well as DMS, the degrees, minutes, seconds form of writing angles. Now, first, I want to start off by pointing out that these three angles I have in black ink up here all look the same, but actually all three represent different angles. Now, the standard position of an angle is a ray emanating from the origin along and going out along the positive x-axis. As you can see here, I labeled the initial side. That's where it starts. And then just imagine that rotated in either direction to create an angle. Now, you could easily rotate counterclockwise and create this angle. You could rotate counterclockwise and create that with the same look of an angle. Or you could rotate 360 degrees and then a little bit more and make it look like the same angle as you're rotating. Now, when you go counterclockwise, that represents a positive angle. And whenever you go clockwise, that represents a negative angle. Now, we're going to learn through lessons in the future that these are all referred to as coterminal angles because all of their terminal sides end up in the same place. But they are in fact three different angles. So if I wanted to draw an angle in standard form, I would first start by drawing a ray and pointing it out to the right. So kind of along the positive axis. And if I wanted to create 45 degrees, which is about half of a right angle, I would put my terminal side up there. And what happened was I rotated from the initial side to the terminal side 45 degrees. And that's how you draw an angle in standard form, which it can be very helpful when you're trying to visualize these rotations. Now, if I want to go negative 90, again, I'll have my initial side, which is a ray pointing out to the right along the positive x-axis. But now, since it's negative 90 degrees, I'm going to rotate clockwise to find the 90, that right angle. So as I rotate clockwise, it'll be pointing straight down. But now I'll have a right angle, but I've rotated clockwise to get there. That gives me that negative 90 degree angle. And my terminal side ends up over here. Now, if I want to represent an angle of 225 degrees, well, I know this is 45 degrees more than 180. And I can easily find that out just by subtracting 180 from 225, just to kind of show that. So when I go to draw this angle, I'll start with my initial side, point out to the right along the positive x-axis, and then I'm going to imagine that 180 degree rotation, which is a half rotation, and then I'm imagining it goes 45 degrees past that rotation, creating that 225 degree angle. Now for 405 degrees, that's more than a full rotation, which is 360 degrees. So if I were to subtract 360 from 405, I would end up with 45 degrees. So that helps because now I can start with my initial side. And then I'm going to do a full rotation, and then I'll end up 45 degrees up after a full rotation. That's 405 degrees. So as you can see, it's very important to signify what your angle is, because both 45 degrees and 405 degrees look the same, but the rotations represent different angles. Now let's talk about DMS, degrees, minutes, and seconds. It's a way of chopping up a degree into many parts to kind of signify accuracy. So instead of using a decimal, it's a different way of really honing in on how specific a certain angle is. Now, one full rotation is 360 degrees. Now, 1 degree can be broken up into 60 minutes. So imagine a tiny degree being split up into many different parts. And then each of those small parts, each of those minutes, can be broken up into 60 seconds. So 1 minute is a 60th of a degree, while 1 second is a 60th of a minute, which is a 60th of a 60th of a degree. So very, very specific. Now, if I wanted to convert 50 degrees, 6 minutes, and 21 seconds to a decimal in degrees, I would just have to first separate each of those parts, the 50 degrees plus 6 minutes plus 21 minutes, and then use these conversions to put it into that decimal form. So as I go through, I don't need to change 50 degrees, but I'm going to look at 6 minutes, and I'm going to change the minute to 1/60th of a degree. Then I'm going to look at 21 seconds and change the second into a 60th of a 60th of a degree. Then I can plug this into a calculator to give me a few decimals to use, which hopefully you can figure out that 6 over 60 is 1/10, which just leaves me with 0.1 of a degree. And then I couldn't necessarily do a 60th of a 60th of 21, but that should have been red. But when you plug all that in, you end up getting 0.0058 degrees. So when added all together, I get 50.1058 degrees. Which is very accurate and good for like computing, but sometimes you can visualize about where that is along 50 degrees. You get to 50 degrees and then you go up about 6 minutes, which is about a 10th up, and then about a third up along that minute to really focus in on that angle. So a little bit easier to visualize DMS, but degrees are probably more universally accepted. Now, let's say I wanted to take a decimal form of an angle and put it into the DMS form. Now, I'm going to start off with first me separating the full degrees, 21 degrees, from the 0.256 decimal part of the degree left over. Now, just like you saw earlier, that 50 carried its way to the end, so this 21 is already done and taken care of. But now I need to convert this degree into minutes. So I'm going to take 0.256, and I'm going to multiply it by 60 minutes, since that's what 1 degree is equal. When I multiply that out, I get 21 degrees, and then plus 15.36 minutes. Now, I'm going to round my answer to the nearest second, so I'm going to take that leftover decimal I have for my minutes, and I'm going to convert that to seconds. So now I have 21 degrees plus 15 minutes plus 0.36 minutes. So now I'm going to convert that minute into seconds. So I'll have 21 degrees plus 15 minutes plus 0.36 times 60 seconds. That, when multiplied, will leave me with 21 degrees plus 15 minutes plus 21.6 seconds, which when rounded to the nearest second is 22. So my final answer is 21 degrees, 15 minutes, and 22 seconds. And that is how you draw the standard position of an angle, as well as how you convert between degrees, minutes, seconds, and decimal degrees.